read.
Today is July 2nd of 2025, and this is the Endo meeting. We have special guest star David Thompson and possibly Christine Weber showing up soonish. And the topic of the day is, hey, what if local VATs could communicate directly? How would we set that up with UNIX domain sockets or their analog on Windows? And we've begun discussing the two versions of topologies. Basically, by way of contrast, there's a hub and spoke approach where there's a kernel locally that,
It,
yeah, go ahead, Chip.
it's more complicated than that. So the kernel, uh, the kernel is in incorporates some of certainly the swing set kernel, uh, and by extension the MetaMask kernel, OCAP kernel, by virtue of the fact that it is descended from swingset, um, um, incorporates the need that Agoric had for deterministic execution in multiple parallel replicated environments. And so it is very important to control the order in which things happen, which is hard to do with a bunch of independently executing processes. And the thing that the kernel provides is a synchronization point, and the swing set execution model says deliver a delivery, which is usually a message, but it could be other things. Deliver an event to a VAT, allow the VAT to process that message or that event or whatever it is, to quiescence, at which point the VAT has relinquished agency for further independent action, at which point the kernel takes over and pulls the next thing off of its queue and hands it to whatever VAT it goes to, lather, rinse, repeat. And so although you have a system of n independent processes, in fact, it's executing in lockstep as if it were a single thread. And that it gives you the determinism you need for replicated execution at the cost of being slow, and not being able to exploit the computational parallelism that you may in fact have at your disposal. Now, the next step after that was to realize that it is only at the point of completion of what we call a crank, which is the processing to quiescence of some event, that we need to maintain ordering. And as long as the kernel lines up the completions of all of these things in a consistent deterministic order, how the things themselves actually execute is less important, and these things could in fact compute concurrently. But you're still running things in what appears to the outside world to be this lockstep fashion, so you don't get the full benefit of that parallelism. So the next step is, in the case of the MetaMask OCAP kernel, is to say, actually, we don't actually care that much about that determinism, because we're not trying to do replicated execution. So in fact, things could complete in an arbitrary order, just as they would if they were independent kernels sending messages to each other over the internet. And so we can break some of that dependency and just let everything run and process messages at whatever natural speed it is capable of doing. But that currently we're only doing between kernels. Actually, we're not even doing that yet because we're still debugging that code. But within a given machine, a given box, where it might have multiple VATs, it's still doing the lockstep thing. And if you give VATs the ability to communicate to each other independently of the kernel, then you can break that final point of mandatory synchronization and just let things run. And you still need a sort of vestigial kernel-like thing in order to manage the sort of bootstrapping of connectivity. But now we're in a world which is much more like essentially like it would be if we had communicating kernels where every kernel had exactly one VAT, at which point the 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 kernel and the what we call the VAT supervisor, that the thing that actually sits on top of the user's code and enforces all the rules, kind of merge together into a single entity. Um, and you can just have however many of these you want to have. That seems like a fairly large number of indirect steps away from where we are now. But I can see ultimately the argument for wanting to do that in order to get maximal performance.
Right. And so this came up for us also in a parallel thread because Kumavis was implementing OCAPN. OCAPN has three-party handoff sort of at the it shows up faster.
Mhm.
When
Right. Well, the thing is that is in the VATs linked in a hub and spoke pattern through the kernel, three-party handoff is not a thing because um, the VAT each VAT just talks to the kernel. Um, um, Sorry, I'm hearing the Henry Cabot Lodge poem. The VAT speaks only to the kernel, and the kernel um, uh, talks back to the VAT, so that sending a message to another VAT is always talking to the kernel. So there's no three-party handoff. The kernel is the communications medium. Um,
until you get to the comms vat. Once you get
well, that's the thing is uh, now we're talking about communication to some other kernel, which is genuinely independently executing, and now we actually have to implement three-party handoff.
right. Yeah, so then if you're implementing three-party handoff, you have the option of so like David, I think that there are kind of implied tiers of OCAPN or CapTPs. Like there's a CapTP behind the scenes where three-party handoff doesn't exist, and then peer-to-peer CapTP where three-party handoff begins to show its face.
Right? This will inevitably end in tears.
Yeah. So Kamavis asked the right question. It was like, what if we could dispense with the hub and spoke topology and have more or less direct communication between VATs, even across peer-to-peer boundaries. And so we went through the thought experiment, arriving where I think Chip has already been many times before, where there's essentially the kernel withers away into being just a process that's purpose is to synchronize and spawn VAT processes and introduce them to each other using the whatever analog of passing a file descriptor or a Unix domain socket over a Unix domain socket is. Um, eh,
And the Unix passing a Unix domain socket is passing a file descriptor through a Unix domain socket is itself an optimization because uh, you know the base
yeah, you
case
could trampoline. Yes.
is these two VATs are in two completely different computers on talking over the internet and that has to work.
Yeah. Um, as it happens, the web has an API that papers over platform differences on like named pipes versus Unix domain sockets, and that's that you can pass message ports over post message. Um, and that's all built on top of whatever your browser's and analog is for Chromium's. I think I found the link for it the other day. Mojo, I think it's called Mojo.
Yeah,
In
that's the
any
thing you sent.
yeah, so they So it's a solved problem if you're standing on top of the web. You can trivially move a file. You can trivially create message ports that do piping between processes. Um,
From one browser to another?
Not from a browser to another, but within like
Okay, well
within,
then that is essentially the moral equivalent of Unix domain sockets on a
yes.
single box. Um,
And then WebSockets, which largely implement the same API but stretch across the web, but don't
right.
allow you to transfer,
Oh,
that don't
don't
support transferring
get me
message ports.
don't get me ranting about WebSockets, please.
Sure, or WebRTC or whatever. The
Yeah.
there is a mechanism.
Well, there is a mechanism for establishing connections, but there is no mechanism for handing off a connection from one machine to a third machine.
No, no, and
And
that's
it seems like that almost is starting to feel like, since we're wanting to have the same building block abstraction and all of these different operating contexts, um, it feels like we'd almost want to have almost a more formal specification for that protocol that kind of abstracts away all of the environment specific details so that somebody could just implement whatever that is and have it available as a library that you can just use the same way in every one of these environments. And that I think could be like just super, super useful for the world at large as a thing in and of itself. If you could have something which was the moral equivalent of passing a file descriptor through a domain socket, but which worked between machines, that would just be awesomely useful.
I think that for OCAP and like we don't have to boil that particular ocean to succeed. I think it just
Yeah,
amounts to
yeah.
being able to
I'm
serialize references.
I'm
And,
just saying
yeah,
it would be great if we didn't have to keep re-implementing this damn thing over and over and over again.
yeah. Well, maybe OCAPN will be the time, the last
Maybe,
time.
maybe we can hope.
In that scenario, are you referring to like directly connecting, say, two browsers together?
Yes.
Yeah, that would be great. I don't think that people doing a lot of the web standards take that use case particularly seriously.
Yes.
So
That has been connecting two web browsers together has been the
Oh, I don't know.
focus of my effort for the past couple of months.
I think that they take it extremely seriously. It's just that it's a field filled with bones of everyone who's tried to find a solution to that problem, and we haven't gotten to the end and made a road. Um,
Yeah, it's like, oh, I want to, yeah, I want to go to W3C meetings and say, die, all of you die.
oh, but it isn't their fault. It's
I maybe not, but it's the fault of a bunch of those people. Maybe not with the intention of doing foolish, evil, destructive things, but with basically just dealing with whatever the local problem that they were trying to solve, um, very locally, and coming up with sort of lots and lots of independently incompatible building blocks.
yeah, and I guess WebRTC is as far as we've gotten.
Yeah.
Yeah,
yeah,
And
that's a mess.
WebRTC isn't even, as it is, we're already abusing WebRTC because it's really not what it's designed for. It
Right.
just happens to have some of the critical affordances that we need to do the job we're doing, but we don't care about like streaming audio. I
I
mean,
mean
I guess
I mean
ultimately we
it's
do, but that is kind of not the focus.
this is it's hilarious. It actually is a mirror image of SMS, right? SMS is just piggybacking on the old control protocol that the phone network used to use for strictly for its own.
Yeah, yeah. SMS is piggybacking on the ring somebody's phone for you.
Yeah.
They can establish a call.
Um, yeah. Yeah. Uh, okay. So, yeah. Christine points out XMPP jingle in chat.
Oh, XMPP.
Rest in peace.
Many, many bad.
I mean, I think that Chip, we can simultaneously mourn the loss of XMP and
I don't mourn the loss of XMPP at all. I wish to have had the opportunity to strangle it in the crib, but I didn't.
but perhaps something that existed that was JSON based would meet your approval.
That's not the problem.
All right. Okay. So let's David, we've spoken a lot.
Do you want to hear about anything in particular? Like, I mean, just getting back to Unix domain sockets, Christine, Jessica, and I have been just kind of exploring the space because there's a number of things we have to educate ourselves on, and also there was missing things in our language to actually do this stuff. So now we have a, we have our base prototype where we can actually, we've got our little scheme programs that can pass file descriptors over the Unix domain sockets, turn them into scheme parts, talk to each other. We had the interesting problem of, in doing this with sending file descriptors over the domain sockets, there's other system calls that have similar problems where you have multiple distinct file descriptors that are pointing to the same underlying kernel resource, and you want to ask the question, are these the same? Especially if you think about trying to establish a single connection to appear in OCAPN, and people are you're getting handed file descriptors over the socket, and we had to, we were looking into how do you answer that question, and at least on Linux, there's a system call called KCMP, KCOMP, that will take two process IDs and two file descriptors, and will tell you whether or not they are the same, and also gives you other interesting information about there's some kind of sorting stuff it does. So you can actually, it gives you like a greater than, less than thing, I guess, if you want to have like a table of canonical file descriptors, and you need to like binary search through them to see if you can find one that's equivalent. And so we got there today in terms of like trying to like wrangle file descriptors, but like we're still thinking about things like third-party handoffs, and probably the bigger problem out of the whole thing is like, what's the what socket do you connect to begin with anyway with bootstrapping this thing? There's different approaches where you could have a particular VAT could have there could be a socket on disk that you use just to talk to that. There's kind of the more there's some kind of daemon out there that is like a global kind of thing on the system, and you use that to facilitate the connections to kind of discover your peers or something if you have some kind of identifier to reference it. And we're working through all that kind of stuff right now. Like Christine and I are pretty amenable to like the there's some global daemon thing that you talk to. I mean, we're like on Linux and stuff, you're used to talking to like dbus or something for things. It seems analogous to that. Okay. Jessica's less keen on adding things to like our trusted computing base. But in any case, these are kind of the things we're exploring right now, and we're kind of just getting started. But our use case for all of this is we have this distributed Shepherd project going on right now. And Shepherd, if you don't know, is an init system. It's under the GNU umbrella, but it's notably used as the init system for the Geeks distribution, which is what I'm running right now, and many of us at Spritely. And the idea would be to goblinsify this thing, OCAPNify it, and being able to control services not only on a single machine, potentially multiple different instances of the Shepherd, but also across machines. And so we're looking at the domain sockets for the single machine swarm kind of use case. On my system, I have a PID1 Shepherd. I also have a user Shepherd that handles user-specific services, and I might have others for like development projects. And you could wire them all up together through OCAP in a Unix domain socket that way. So that's just kind of a big overview of like where we are.
Yeah.
That sounds very reminiscent of what DHCP does. And before that, what was it called? BootP?
Are you talking about in terms of like discovery?
Yeah,
Or-
well, just how do I begin talking to the world when there's no established relationship?
Right.
And
Although in many ways we're just talking about how do you talk to the world on just on one machine without even like a wider network. But
Right,
of
but
course
I
it,
mean, this is a problem which crops up in different contexts, but has a same general flavor.
that's true. Yeah. And Dave mentioned that Jessica is suspicious when we add when we're talking about, it turns out one of the approaches, so we talked about some more direct approaches, which is, you know, like there's the equivalent of a sturdy ref, which would be like a you know, a process or VAT has a Unix domain socket it's listening to on disk, that you have that, and then let's say a Swiss num or something like that, and then you can do the equivalent of a sturdy ref through kind of combining those together, and then from there you just bootstrap into the world of you know, like sending around Unix domain socket things to kind of do everything else. And that one would be kind of nice because I think it avoids the trouble that Jessica perceives correctly of having something like a singleton. Although it does use a file system as a singleton, of course. But then when we also, one of the other things we were exploring was, well, what if we had, you know, this like daemon that was running that you could talk to, and you could prove that, you know, you had the ability to talk to this, you know, and it can do introductions, and it's just there for bootstrapping. But you know, every time we end up doing something that involves some sort of singleton, you know, a tiny piece of centralization to bootstrap the decentralization thing, just you can just see like Jessica like make a scowl, and rightly so, even though that's sometimes what has to happen.
That's a great instinct to have.
Yeah.
It puts me in mind of Bill France's quip about, of course, having a single global namespace is useful. That's why we have so many of them.
Yeah.
yeah,
So
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 you're
so
in.
I guess it's interesting to so Dave, do you want to talk about the did you talk about the KComp or
Yes, I did.
KCMP stuff yet?
Yeah,
Okay.
I did. If and I'm sure if anyone else here is familiar with it, because I certainly wasn't until this morning.
It's obscure. I haven't heard of it.
Yeah.
Um, even if, even, yeah, even though it exists, I know it doesn't surface to all of the layers at which it would be useful on every platform. The
We okay, so go
so
ahead.
so so my question would be, do we actually need it? I mean, we might need it. Okay, so basically, I think that the shape of the problem is that we're assessing different ways to do grant matching. Um,
Right. Do we even need EQ? Right? Do we need the ability to test for whether or not two things have the same address? And the and for we did a like kind of a thought experiment, and you know, Jessica kind of challenged us of, you know, well, I mean, we have hints. Like, wouldn't it? Let's assume that we authenticated the message some other way. And like, let's say we use cryptography, right? We you know, we sign every message. You know, Mallet can't get in the middle and fake messages. Mallet could observe them. Maybe they're, you could even be even stronger and they're authenticated and encrypted, right? You know, and then Mallet wouldn't even know what they were. And the worst thing that Mallet could do was a network monitoring attack to find out when these two participants were talking to each other, which we still don't like, but you know, it's certainly not as bad as some other things. But then when we were talking about it, we were like, oh shit, this is way more dangerous than it is in the normal network case when we are talking about the Unix domain socket case, because the danger is, if you think about, if you have the usual, you know, Alice is introducing Bob to Carol introduction we're also familiar with, and then if Mallet is doing some sort of thing to say, oh yes, this is Carol, and you know, and wants to try to trick Bob into thinking that this is Carol, and you know, maybe especially if this connection is reused and like Mallet is trying to be in the middle every time or something like that, and so mallet does the first introduction and kind of keeps getting that's the pairwise session between B and C is actually between B and M and C, right? The dangers are actually that authenticated messages are not sufficient. And the reason is that the capabilities are not just being transmitted on the wire. If mallet is intercepting the, hey, I'm sending you a signal that you should pull a socket off of the wire, mallet is in charge of which capabilities are actually transmitted at that point, because there's no way to sign the actual uh, sockets on the Unix domain socket that are being handed around, right? There's no way to sign those. So we determined that we had to have an EQ equivalent. I see you're looking. Your eyes are off and to the side, Chris. This is you're contemplating this very thoroughly. I'm curious what you're thinking.
One of the things that you said made me realize one of the things that makes three-party handoff tricky and subtle, it has to do with message ordering with respect to messages which are in transit during the handoff. And it's interesting to contrast this with the case of I publish a URL that's in a QR code printed on the side of a bus that allows a third party who wasn't previously part of the relationship to connect and in fact establish an authenticated connection, but without attempting to address this messages in flight ordering issue at all, the presumption being that they'd be establishing a new relationship, so there wouldn't be any traffic like that they have to worry about. And in that case, what you've got is you're being less particular about where the reference came from. And I'm wondering if that loosening the constraint about message ordering possibly gives some wiggle room.
So, my understanding is that the crux of this is connection reuse. The crux of grant matching is connection reuse. We need to be able to ensure that the network is able to recreate the pass invariance of object identity of EQ, as you put it. I take it as table stakes that you need to have a guarantee of a single connection to each other connected VAT.
Yeah, there are several tables involved.
Do we in this room have a shared understanding that that is certainly at least possible with the singleton-daemon approach? Is that right?
It should be possible if you trust the daemon, that you can trust the daemon to be able to say, oh yes, this is the connection to this thing. And then anytime you see that future thing, you can either have cached knowing what that connection was, or you can just ask the daemon again and it'll point you at the same thing. But yeah, that should be possible.
Okay.
The crux of the grant matcher challenge is how can you cope in the absence of a trusted intermediary? And if we posit a trusted intermediary, many things go away, or at least are reduced to a previously unsolved problem.
Yeah. Okay.
To comment on your comment, Dan, about you better trust the daemon. If we elevate the daemon to our TCB as in terms of being part of our kernel, then yes, you absolutely had better trust it. But you could, one thing we were talking about this morning is that trusting the daemon as a kind of god, right? But there is an alternative demigod approach where the daemon is merely an introducer, right? Where you may have multiple daemons on the computer, and if you are able to verify that the things that are set up are correct, then it's closer to for like, edge names in a pet name system, it's just, like being introduced through somebody else, and you can use all the rest of the EQ things that you have. So the right, exactly, trust but verify. But there is a point where if you there's a point at which in your TCB you should be able to not have to you have to bottom out to a point where you trust and don't dare verify. That's a really tricky part, right? And there's always part of your TCB where you're doing that, where you're assuming, okay, the physics of this world actually operate the way that I believe that they do, so that I can make any sense of everything else.
Okay, so let me the architecture I am imagining, it has two tiers. Um, there is a tier where it is, and there is a tier where grant matching occurs over a network and requires cryptography and cannot have a central authority, right? And on that, you don't need Unix domain sockets. You just need a listening port and a public key, right? Is that right?
Wait, say that. Can you restate it?
Yeah, I see that there are two tiers, and you could assume that there's only one tier. If there were only one tier, it would be the tier where you do not need Unix domain sockets at all. You need a listening port, like a stable listening port that you can use as a connection hint on a stable IP that you can use as a connection hint with a public IP or public key, and just use cryptography or for introduction and for um, confidentiality. Is that right as a baseline? And with that as a baseline, any two peers can be connected safely and establish grant matching through crossed hellos, et cetera, et cetera. Is that right? The
I think I missed the part that I believe the answer is yes. Let me restate to see if I understand. Um, if we're doing network based communication with well understandable routing mechanisms, and then we have data oriented approaches of being able to send things around, we can manage to ensure security generally. Now, of course, if we do have a system that has hints, we still have the problem of mallet being able to possibly set up a man in the middle if the hints are the path to which a connection is established. There's still the possibility of a network monitoring attack. However, network monitoring attacks are not the same as interference. The reason that there is a possibility of interference here is that we cannot sign a Unix domain socket being pulled off the wire because it's a very live thing and not a data thing.
It's not bits. That's sort of the point of it, is that it's not bits.
Yeah, once you descend to the Unix domain socket, you get better assurances, assuming you trust your kernel, right? Somebody has to sudo to do live PCAP monitoring of your connection, and even that is kind of um, hard to sift through, and doesn't guarantee that you see the continuity of the stream. Um, Ask me anything someday. The the uh, Yeah, so there's a local value. If you're on a multi-user system, you can get better assurances, assuming you trust your administrator. Um, but I don't think that that's particularly interesting. The network case is interesting. Most people are on single user systems. Multi-user systems tend to be VPSs these days and fall through to the network case.
What was that initialism you just used?
Virtual private servers. Hypervisor, like most people don't have more than one kernel per user anymore. It,
Fine.
it's not the Solaris days anymore.
They don't have more than one user per kernel.
Yeah. Yeah, the connection hints man in the middle attack is, yeah, again, gives you gives the aggressor in that attack has the ability to pace your connection, right? That's the downside. Christine?
Sorry, I was responding to Dan. Can you restate the question one more time?
Yeah, the downside of an intermediary being able to rewrite your connection hints is that they can interpose someone who can observe that you are connecting and also pace that connection, but can't observe the content of that connection.
Right. So for the moment, here's an example of an of attack that we might be concerned about. I want to set up a private communication with Chip. Tell Chip about the secret kryptonite for capability security that's going to destroy all of the stuff that we've been working on for decades. And I want to make sure it's a secure connection. And I assume nobody's broken the substrate of capabilities in the meanwhile, right? But and we have this nice capability-based chat program, right? So I want to send a message to
And
Chip.
also we can assume that the only reason Christine would ever talk to Chip at all is if you have found some OCAP kryptonite.
That's right. That's right.
Right.
So anyway, so I'm reaching out to Chip to talk about this or whatever else, right? Um, uh, actually, that does become an important part of the story that I added that unnecessary detail because the let's simplify the story. Mallet wants to know when Alice and Bob are talking, right? And so Mallet, um, if Alice was going to imagine that Alice is the one who's going to connect to Bob for the first time, right? If Alice had handed a capability to Bob, sorry, if Bob had handed a capability to Alice that says, "Hey, here's where I am, and also here's some hints of how to be able to send a message to me," and Bob really was the first time that managed to get that to Alice, then it would be no problem because Bob, the hints that were in there would actually be some sort of path that Bob was relatively confident and comfortable with. But the fact that Bob may have included but if Mallet is the first one to send this thing um, to Alice, then Bob could say, "And here's a hint," and that hint routes the messages through Mallet's server. Now, what can Mallet do? Um, if Mallet is, like a person that wants to be able to know when they're talking, because maybe Mallet's a state actor or something like that, and they're activists, right? Mallet can find out whenever they're talking, and therefore that's useful information.
And
Mallet could also do other things.
the volume of the message, the throughput of that traffic, right?
That's right. And in the size of the messages potentially and all sorts of other things. And Mallet can also do other things, right? Mallet could frustrate the connection by disconnecting it at inopportune times. And Mallet could also slow that connection to a trickle, and Alice and Bob might not realize it. And even if Bob hands the thing to Alice later that says, "Here's how to reach me," if there's already an A-B connection that was forged through the Alice-Bob relationship, and that session remains open, or it's some sort of stored in some database as here's a reasonable way to connect, I've done it before, um, Alice will keep doing the messages through Bob, even if Bob provides a different path, right? So that is the challenge that we're concerned about.
Why would that follow? I missed a step.
For grant matching, we hold one open connection.
So
Well,
in
and
yeah, in
the first
like
one wins for the
right, in
Yeah, but
duration of the session.
in CapTP, typically if we have the VAT TP layer, right, the net layer version of things, if we've already got a connection open between A and B, and you get a sturdy ref that says, here connect to this object on B, we don't open a new TCP connection between A and B.
but you
We
could.
use the one that's already there.
I mean, you could have a handshake that says, "I'm skeptical of our channel. Let's set up a new channel, and if the channel is subject to traffic analysis but not content monitoring, then possibly the eavesdropper could infer that, hey, they're setting up an independent connection between each other, but it wouldn't be the monitor would not be able to actually interpose themselves on whatever the new channel was.
I mean, being able to observe that there's a problem in the first place is something we shouldn't expect our users to have to figure out that they should introduce a challenge for. We as a protocol authors should be doing it. I mean, but it could be that when there's so there are solutions to this, and we have talked internally at Spritely, but have not proposed yet how to do this in OCAPN, mainly because the dial back authentication and some of the connection authentication stuff simply hasn't been put into OCAPN yet at all. But there are solutions to this, which is that when you connect, you could actually say, and here is the hint by which I'm connecting. And then if either Alice or Bob, whatever enter the thing, says, oh, that's no good, that's actually not within the set of hints that I consider to be acceptable, they could just kill the connection right there.
The handing off, like straddling multiple concurrent connections, is tricky. Like that's a really hard problem because it's a running session. The new session has to presume the same exact C list. They have to presume that they have the same C list and the C lists are in lockstep. That'd be pretty hard to pull off. You'd have to have like checkpoint hashes and stuff like that, and like Merkleize your C list.
I'm not quite sure what you're talking about with that one.
Well, when Chip proposed that if you got suspicious of that a connection might have an intermediary, or suppose that we generalize the problem, that our general solution is that you can and will maintain multiple connections between peers, but only one of them will be, and that they will collectively represent a single FIFO session with a single shared C list. That's
I see.
that's tough.
Yeah, I mean, the thing is that there's an underlying question of how do you establish connectivity at all in the first place? And in the case of, for example, TCP, you're reliant on the internet backbone router framework for that, and which is known to be heavily compromised and heavily eavesdropped upon, but which nevertheless allows you to establish a connectivity that somebody cannot follow the bit content of. But I'm just wondering if I'm kind of uh, plucking things from air here. But if you were suspicious of your TCP IP connection that you have through AT&T or Comcast or whatever, you might set up some other thing where you, I don't know, make a conventional analog phone call somewhere and do, I don't know, just some completely different communications medium. Now that would be very heavyweight, high overhead kind of thing to do. Probably not practical, but it hints at um, um, alternatives, and also the fact that um, the internet backbone as such is not monolithic. It is the emergent
Yeah,
behavior of lots and lots and lots of different parties and companies and
their peering arrangements.
and
Yeah.
all of their arrangements and all of that, which has enough chaos and complexity in it that there are many, many avenues for exploitation, but it also means there's many, many avenues for evading things. And because the operation of it is generally opaque to the endpoints, and this kind of sort of the whole point of the thing, it doesn't give you good affordances for saying, I don't want to route through this vendor, I want to route through that vendor. But as I say, at least hints at the possibility that you could establish alternative connections.
There's a balance here that's tough. I for one think that it's very useful that hints can be transformed because uh because a relay would be in a position to transform the hints on your behalf, and that may actually be a feature for purposes of IP masking. The Right? Like if you were to share a locator through a relay, the relay being in a position where they can change your locator, change your connection hints to be connection hints that use the relay as a feature. You could use that to
Interesting.
mask your IP. Whereas, um, yeah,
Yeah, I mean that interesting. It's because
but
essentially
because of that feature, there is the possibility of a relayer of a malicious relayer eavesdropping on your traffic. And I like, is that I think that solving that problem might be a non-starter. As Chip points out, network traffic, there are a lot of places to stand to, um, there are a lot of places to stand in order to either offend or defend on that front.
There are a lot of places to stand, uh, um, there's a big difference between um, you have to be part of the internet infrastructure to be able to perform this type of thing versus you can be somebody's abusive spouse and do
Yes,
this type of thing.
right,
Um,
right.
and so I think the stakes are not quite the same in all scenarios.
Hmm.
And really the idea of authenticating hints is to which again it like this is kind of the first, well, actually, it's the second time I brought it up to the group. The first time was very early in the OCAP and stuff. But it may have been before, like in the pre-call that we had, like a year before the group really started.
I
But
remember this scenario. Yeah, I remember this has
yeah,
come up before.
but I think that I'm gonna pivot to an anecdote, which is that this conversation I think is troubling to OCAP people consistently for the same reason that the grant matcher conundrum was troubling in the first place, which is that it starts to move into the domain of things that you can point at with a name, and things that have kind of a sense of ambience about them, and kind of stuff that starts to look more like ACLs and less like identity is kind of being the inverse of OCAPs in certain sense. So the fact that and there's a anecdotal from Fryam at one point where I kept talking about the grant matcher document talks about Lisp's EQ argument, and sometimes in the scheme world I've heard people call that eek, so I was saying eek over and over again, and Alan Karp was like, why are you saying eek? And I'm like, oh, EQ. And Alan's like, I've never heard somebody say that before. And Kevin Reed jumped in with, if you know what eek is, you might call it that.
Mm.
you.
That's a good one.
In any case, I like the idea of having the option of uh, authenticating hints, like as part of the connection handshake. It's like, what hint did you use to reach me?
So
And
so so it seems like an optional thing when we're talking about general OCAPN. Now that we're talking about a variant of OCAPN that has some out of band of the message stream ways of establishing connections, where the message stream effectively points at something that's out of band, it moves from a nice to have to a must have, for the very reason that I talked about, where mallet can start actually inserting different capabilities. Like you could imagine that Carol keeps saying, "Oh yes, and here's a capability, and here's a capability, and here's a capability," but and so like grab this off of the off of the socket, and grab this off of the socket, and grab this off of the socket. But mallet, having inserted itself in the middle, is actually putting things onto that live wire that are completely different capabilities in every case, right? And that,
I don't understand.
okay, let me walk through this because it's very important. It explains why this is a must and not a should or may or whatever. Because this is critical for us getting the Unix domain socket stuff right if we're doing connection reuse.
I don't want to even talk. Are we talking about Unix domain sockets at all yet? Are we?
Well,
is this
I was
germane
trying to
at the network
distinguish
level?
between why the grant matcher thing is maybe optional on the network generally, but it's not optional in the Unix domain socket case.
Boy, my intuition was precisely the opposite of that. It's optional in the case of the domain socket thing, but necessary on the network.
But the problem becomes if you want to, you have to have, let me put it this way, you have to, if you want to have connection reuse between you, let's say these are 3 different processes on the same operating system, and you still want to have Unix domain socket connections between B and C that gets reused, right? When A sends a message to B to say connect to Carol on C, B says, oh, I already have a connection to C, and doesn't set up a new a new Unix domain socket pipe, right? It's able to say, oh, okay, I'll just keep using the one that I have. And there are many good reasons to do this. Avoiding extra file handles is one. Also being able to continue to have, identity equality and all sorts of other things are others. And shortening in general is just appropriate. So taking it as a given that that's something we want, now it's more dangerous because imagine if you do not have an EQ equivalent, right, in this scenario. And some of the capabilities, you have a stream of messages. Let's say there's a CapTP stream that says, oh, and we add a special thing to OCAP and that says, and now grab one of the special on the wire capabilities, and now grab another special on the wire capability, and now grant another special on the wire capability. So how does B know that it is talking to the same C? And the fact that if mallet is between B and C, if C is saying I have I have a new capability for you, B, if mallet is sitting in the middle, sharing the same messages or whatever, mallet, even if these are authenticated with encryption, B can still mallet could still actually say, oh yeah, you said you wanted to send this secret message or do whatever type of special thing. I'm actually going to hand you a separate capability that you grab off the wire every time, right? So that's the danger, is that we can't, it's not data we can sign because the things that are slurped off the wire are not signable.
Do you mean grab off the wire capability? Are you referring specifically to a domain socket that is paired with the message on the channel?
Right. So this is assuming that the
Because
way
you
that we
can't-
might end up doing.
Right.
Yeah.
The point is you can't sign the socket.
Yeah.
Yeah,
Okay.
you can't sign that
Okay.
message you send over.
Because
It's all fixed.
Right. It's not bits.
And that's why I say that this moves from a should to a must in the case of
A should to a must, presuming that you do not trust a daemon, right?
presuming you don't trust a daemon. That's correct. If you trust a daemon, then you have a way to be, effectively you're letting the daemon do EQ.
Now,
Right,
by
for
the
you.
daemon, are we referring to like the Linux kernel, or are we referring to some other entity?
It's a user mode process that stands in a privileged position.
It does introductions.
Yeah.
So if you ask B, if A is introducing B to C, then it's actually this daemon that does the initial introduction between B and C. So if you trust the daemon, then you have a very easy way to trust that over and over again that you're getting the same connection to C. So yes, you're completely right. FN, like the what is it called? F control, or what is it? I'm not looking at it at the moment. It's not. Yeah. It's KComp. KComp. That's the one. KCMP. That's a different 4-letter word.
Yeah,
Uh,
right.
different 4-letter word, and so do we need that? And the question is, this is basically going off of what Jessica's pushing hard on, right? Jessica's saying, I would like to be able to see if we can avoid this daemon and do purely direct connections, etc.
I see.
Yeah, I think her instincts are sound.
Okay. Yeah. Okay. So I am in agreement, at least, that as an exercise, we have as an existence proof that we can solve the problem using a trusted daemon. That is icky, or eeky, if you will. Um, and yeah, and if you do not have that place to stand, then yeah, you would
Well,
need to be able to do you would need to do grant matching on the file descriptors themselves.
so once again, today seems my day for seeing parallels between different universes. I don't know, maybe it's because I was talking to Ryan about category theory the other day, but so one of the key insights of a lot of the blockchain stuff was financial protocols typically relied on a trusted third party. And what blockchain has done is it hasn't taken away the reliance on a trusted third party, but the trusted third party is an emergent phenomenon that is outside the control of any particular entity. So that the third party is this thing that kind of appears as if by magic as a result of the logic of and it feels like there's a similar thing here. I'm not quite sure how. I mean, I'm kind of grasping at straws here, but it feels like there is a parallel, which is um, um, if you could synthesize such a daemon from a bunch of um, independent actors who are engaged in some kind of mutual protocol. Um, I don't know. It's kind of hand wavy and vague, but I think there's something like that you might pursue.
Well, let me state where we stand with the pet daemon. Uh, our choice is in the name. The uh, we actually um there may be some there may be some the where we're standing at the moment is that the pet daemon is not one per host, but one per user, and not even necessarily one per user. It's just one per user by default. There is the potential of having a pet daemon run for specific projects, for example, but for each daemon there would be a distinct public key, maybe even multiple public keys, so that you can have profiles. Each daemon would have one stable system port that it can listen on in order to establish connections in order to receive connections from elsewhere on the network with a stable hint. Conventionally, we're using 8920 as the one user's pet daemon at the moment. If it's a daemon that's reachable from the outside world, the the daemon is intended to be the gateway, no matter how we re-architect things underneath it, because we do need to have that one place to stand for receiving connections from the outside world. We need a listen socket. We need a process to own that listen socket. Um, yeah, and it has both a listen socket and a UNIX domain socket. The UNIX domain socket doesn't interrogate or use cryptography. It doesn't interrogate public keys or use cryptography. It's just if you have access to this UNIX domain socket, then you must be the user and able to do anything they can do. And that's the basis for being able to establish connections with a web browser and among other things.
And how are you identifying a connection between processes on the machine? Are you using Swiss nums with the daemon, or what is the thing for like connecting between different, like for a Unix domain socket based OCAPN, what is that layer? What is your vision of like the identity of things?
The daemon spawns all processes that it is able to communicate with, so it stands in a position where it doesn't well, where it's using file descriptors 4 and 5, maybe 6 and 7, I don't remember. As its CapTP uplink to the kernel.
But if I wanted to serialize a graph of connections between processes,
Hmm.
um, and I wanted to be able to reinitialize a connection to this interesting process that's over here that is presumably going to start up again sometime soon as I booted up my computer, just as mine is booting up. How do I end up having starting the connection to that process? How do I address it and say I have a capability in this process? What's my entry point with that daemon?
To Okay, the scenario is a full system restart.
Yeah, so basically starting from a non-live scenario. How do I
Yeah.
end up doing that?
Yeah, at the moment, the mechanism for that is through durable pet named access. You appeal to your host, whatever your host facet is from whatever process you're standing in, so to give you a reference to the pet named thing in another process. That's all we have
I
at the
see. So
moment. We don't
it's
have.
closer to at the start. Instead of me having serialized and persisted something, it's effectively when my process initializes, I'm given a promise to the things. It's closer to the arguments passed in at the start of the function or process
You
are
get
the capabilities I will have.
Right. Your capabilities are vended out to you. You receive a single capability. Every process is no, pardon. Uh every capability is created by invoking a maker function in a particular program that is revived from a content address store, or from disk in some cases. And then it is granted a single capability from which it gets all other capabilities. By convention, that's a power facet that's held by the kernel.
And how do you know that and
Oh,
if
pardon,
A is going to
pardon.
talk
It's
with
it's it's an instance of what we're calling an agent tentatively. Agents have a pet store and and a function for looking up. It has functions for looking up capabilities in its own durable pet store, and a function for requesting further capabilities from the user.
and if I'm wanting to connect to if I so there is no concern about wanting to if I'm if I'm being handed if I'm process B and I am being handed from process A a capability to some object in process C, I'm being handed a reference to Carol, and I
Mhm.
already have a reference to Carlos on C. Um, how do how do I how is the coordination? What is the identity
Yeah,
of
there's Swiss
C?
nums. Yes, there's a Swiss num table that's stable across restarts.
Okay, all right, great.
Yeah.
All right. Well, this is helpful. I see people are dropping off, and it's four of us left, so maybe we're approaching the time where we should drop off too. But this was good to understand the 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 scope of what you all are thinking about, and
Yeah.
for us to be able to share what we've been thinking about too.
Yeah.
Yeah, I hope that we do coordinate more like this in the future. It is a personal ambition that in the very near future that our that we have that we have some shared piece of infrastructure, or just be able to create our own, have duplicate infrastructure that's able to host each other's work. Um, like both all parties using OCAP and all parties having some interchange format for applications that can be hosted in each other's agencies, if you will. And my real ambition is that we get this familiar Electron app into a place where it's useful to both of us so that we don't have to duplicate that effort. And since you're building applications that can run in a WebAssembly container, I think that container can fit inside of a generalized, just here's a weblet container that can run anything Spritely makes. That would be very, very cool.
Yeah. All the browser environment stuff's very interesting. There's still a lot to do there.
Yeah, I am going to lose all of my remaining hair, I think, getting the Electron app up and running. But it should be small. That's my hope. It's a very small thing that we can rely on to just bootstrap this ecosystem.
Would I guess I know we're trying to wrap up, but if you were running something in this environment you're working on, I'm just thinking about like our stuff. It needs access to a number of web APIs in order to actually work.
Mm-hmm.
How do we go about getting access to those things?
Yeah, at the moment, there are some interesting wiggles that I was surprised, and you'll probably be surprised too. The conceit that this is all based on is that I can create a custom protocol handler in Electron. I've tentatively called it local HTTP : right? Where your origin is a swissdom.
Okay.
And with that, like my goal is to write as little Electron as possible and have as much node behind the scenes in a server as possible, since the latter is more close to home for us. So basically, the pet daemon is an HTTP server that the Electron app is a proxy for, and it's the purpose of the purpose of the Electron app is very thin. It needs to be able to translate. Well, its purpose is to make it so that swissnum can be used as an isolated origin for purposes of an imposed content security policy, right? So that if I put a web application inside of a zip file, like literally a zip file that has an index HTML in it, and whatever else assets, I want to be able to open such a thing safely, knowing that it does not by default have the ability to exfiltrate anything, and it has no capabilities by default, but can reach out to the pet daemon for capabilities, including capabilities that extend its HTTP server, like mounting stuff on its domain. So that, for example, you can run video over HTTP. Since OCAPN can't do everything. So basically using OCAPN as a control plane for an HTTP data plane. That's the idea.
Okay.
Yeah, and most of that works. Most of it works locally. The problems I'm trying to solve right now are about just like how the heck do you package up an Electron app so that I can just email you familiar.app in a zip and then start playing with it with each other's technologies. Right. And the packaging is basically that the app has to contain the daemon. So if you don't have a daemon running, it'll start one for you using the version it's got in hand, using the Electron binary as the node binary for running it. So that this can be like a technology that you can in good conscience pass to a non-developer friend and they can just get started. But also a developer friend can run their own like development mode daemon.
Interesting.
That's
Yeah.
cool.
Yeah, that's the idea. The wiggle is that because I'm defining the local HTTP protocol scheme, what do you do about WebSocket? You can't use the same local, like a local WS protocol handler. Well, Electron doesn't give you protocol override hooks for WebSocket. It only gives you protocol override hooks for just request response HTTP, near as I can tell. So I can't proxy WebSocket. What I can do is exactly what I would do on the web for a web page that wanted to talk to an extension. I can inject, I can set it up so that you can pass a message port through your window to your parent, and thereby establish an OCAPN connection over a message port with your parent process. And then, so basically I have the Electron main thread in a position where it can establish real WebSocket connections to the HTTP backend, and just pump messages over a message port. And that works. I got it to work. I'm excited.
Cool.
Yeah, which means that you could, in theory, write an application that uses the exact same mechanism to talk to the pet daemon when it's running in the pet daemon or in the familiar app as it would use if it were trying to talk to a pet daemon web extension, if that were installed in your browser. So then you could like theoretically write an application that can be hosted on the web and still reach out for capabilities in the same way it would if it were hosted by the familiar. Which I think,
That's neat.
yeah, which I think would be neat. So like basically to get where we want to be collectively, we have to establish conventions for how to pack up a zip file, how to structure that zip file so that all of the MIME types get lined up in a consistent way and that kind of thing. And then establish some over OCAPN protocols for controlling or for managing your HTTP data plane as a capability.
Cool.
Interesting.
I'll have to see a demo sometime.
Yeah, I'm hoping to have one soon. Did you see the demo of the pet daemon maybe a year or two ago?
Yeah.
Yeah, it'll be that again, except inside of a native window.
Cool.
So you basically already seen it.
Well,
the real demo would be, here's a zip file that you can open inside of your so that you can start writing your hypercard stacks or whatever we're going to call them. All right. I'll let y'all go. See you
yeah,
all
I should go. But yeah, thanks. It was a good conversation. We'll try to
later.
maybe come to another meeting sometime soon.
Yeah. Catch you all later. Bye.
Bye.